In this video, we are going to discuss about another application of balancing about the principal working of dart tube. Better order with the simplest dart tube. What is dart tube? Working of tube is a tube during the body of flow. At any pipe part, it is rise. G is due to pressure velocity. The pipe may be a then maybe X, maybe canals like. It will that if the velocity of flow at point 0, if the velocity of flow at the point becomes 0, the pressure is increased. There may be increase of pressure, and now the velocity is 0, pressure is ultimately increases. Conversion of kinetic energy into pressure energy. The main use of this one is kinetic energy has been converted into pressure energy. Now, it is the simplest form of Pitot tube consisting of glass tube bent at right angle. Now, maybe the angle of between is 90 degrees. Pitot tube is a simple glass tube bent off at an angle of 90 degrees. Now, it is the Pitot tube. Now, it is a canal. Now, Pitot tube has been bent at an angle of 90 degrees. Now, H is the head and H is the head here. H may be the head and H is the head. Now, whenever the liquid rises up in the tube due to the conversion of kinetic energy to pressure energy. Now, the velocity becomes 0 here. Whenever you dip the Pitot tube here, the velocity becomes 0. Now, the velocity becomes 0, there may be an increase in the pressure. The pressure is called as pressure head. H is the pressure head. H is the pressure head created in the Pitot tube, and H is the difference in the canal. The velocity is determined by measuring the rise of pressure in the tube. Now, velocity has been measured by measuring the rise of liquid in the tube. Now, it has been measured by rising whenever the water has basically by rising the water. Whenever rises, we have measured the pressure head. P1 is the pressure intensity. P1 is the pressure intensity at point 1. V1 is the velocity at point 1. Next, V2 is the velocity at point 2, which is 0. The velocity remains 0 at this point. The velocity is 0. Next, P2 is the pressure intensity at point 2. Point 2 pressure intensity is maximum. H is the depth of liquid in the liquid. H is the rise of liquid in the tube above the fixed surface. And H is equals to we know that V1 square by 2G, nothing but an kinetic head. H is equals to the pressure head has been created by using of kinetic energy only due to the velocity at inlet, that is V1 square by 2G. Now we get R is otherwise V1 is equals to as 2GH. Now V1 square is equals to 2GH. Now V1 is equals to square root of 2GH. This is a way in order to find out the velocity in a Pitot tube. Now, this is a theoretical velocity. Why? Because there is no losses. We are not considering the losses. Whenever we consider the losses, then that velocity becomes actual velocity. Now, this is a theoretical velocity. Then, actual velocity has been multiplied with some coefficient. Now, the actual velocity has been multiplied with coefficient of velocity multiplied with 2GH. Now, CB is called as coefficient of Pitot tube. The coefficient of Pitot tube varies from 0.6 to 0.7. Now, in order to find out XH, CB root 2GH, in order to find out the pressure difference at H measured by H is equals to X into SH divided by SL minus 1, where X is called as SH is called as specific gravity of mercury. Specific gravity of mercury is constant 13.6. Now, SL is called as specific gravity of liquid, where whenever there may be a passing of liquid, whenever it is the water 1, whenever there will be oil, there may be a given specific gravity. Now, specific gravity of liquid. X is the difference of mercury, difference of level in a nanometer. X is the difference in the nanometer, differential nanometer. Comes to the problems on Pitot tube operators. First problem, there may be only one problem. Generally they are given in the question paper also. A Pitot tube placed in the center of 300 mm pipeline. Now the diameter is given as 300 mm pipeline. One orifice pointing upstream, other is perpendicular to it. The mean one is perpendicular. Now always the Pitot tube is always bent at 90. The mean velocity is 0.8 times of center velocity. At the center, the pipe center, the mean velocity is about 0.8. Find the discharge to the pipe. The pressure difference between the two orifices is 60 mm of water. Pressure difference is equal to 60 mm of water. Take coefficient of velocity as 0.98. Given diameter of pipe D is equals to 300 mm. 300 mm means 0.3 meter. Next, difference of head is equals H is equals to 60 mm of water. 60 mm of water means 0.06 meter of water. Next, coefficient of velocity CV is equals to 0.98. Coefficient of velocity is given as 0.98. Mean velocity V is equals to 0.8 multiplied with central velocity. Mean velocity V is given as 0.8 times of central velocity. Come to the solution. How to solve the solution? Central velocity is given by an equation. We know that velocity V1 is equals to V is equals to CV multiplied with P2J is nothing but an equation of a actual velocity of a Pitot tube. V is equals to CV into P2GH. Now the actual velocity is equals to 0.98 multiplied with root of 2 into 9.81 into H is 0.06. Now central velocity is given as nothing but the actual velocity. From that we get mean velocity is equals to mean velocity given as in the form of one equation 0.8 times of central velocity. Central velocity we get V is equals to 1.063. V is equals to 1.063. We get 0.5804 meter per second. Now discharge Q is equals to, we know that discharge is equals to how many meter means area of pipe multiplied with mean velocity. Now discharge Q is equals to area of pipe can be calculated by using of pi by 4 d square. We know that circular pipe area can be found out. Formula is pi by 4 d square multiplied with mean velocity. Next, discharge Q is equals to pi by 4. D square is 0.3 square. D is given as 300 mm. 300 mm means 0.3 meter. 0.3 square multiplied with mean velocity we get just now. That is 0.8504. From this we get discharge Q is equals to 0.06 meter per second. Now the discharge flowing inside the pipeline is equals to inside the Pitot tube is equals to 0.06 meter cube per second. This is the way in order to solve the problems on a Pitot tube. Just Pitot tube. Consider the principle of Pitot tube and working of Pitot tube and the numerical problem on Pitot tube. This problem has been given many times in the question paper.